स्टार्ट कर देते हैं फिर वेबिनार। रिकॉर्डिंग चाहिए
यूट्यूब पे आ रहा है
सर जसपाल सिंह
नहीं चाहिए।
गौरव सिक्की से ज्वाइन करके
जसपाल सिंह ज्वाइन कर
गौरव सिक्की पर तुम सारे पार्टिसिपेंट ज्वाइन कर सकते हैं सर।
Students, are you ready?
आप यहाँ पे
ठीक है। आप बंद करो।
जो शेयर करना चाहते हैं वो शेयर करो।
Good afternoon, everyone. Myself, Manpreet Kaur, Assistant Professor at Yadvindra College of Engineering, Talwandi Sabo. Now we are going to start technical session 1 of National Convention of Electronics and Telecommunication Engineers on Antenna Design for Efficient Communication and Networking. This session is chaired by Dr. Balwinder Singh Taliwal, Associate Professor in EC Department at NITTR Chandigarh. In this convention, we have received several research papers in the field of antenna design and networking. Now in session 1, we have 4 research papers. Now I request the presenter of first paper, that is Ms. Pooja Rani, research scholar at NITTR Chandigarh. The title of her paper is Flexible Variable Fractal Antennas and Overview. Ms. Pooja Rani?
Yes, ma'am, I am audible.
You can start your talk now.
Okay, thank you, ma'am. Good afternoon, everyone. I'm Pooja Rani. I'm working under the guidance of Dr. Balwinder Singh Taliwal and Amod Kumar sir and NITTR Chandigarh. The topic of my paper is Flexible Variable Fractal Antenna and Overview. So first of all, let me outline. I have outlined introduction, microstrip antennas, fractal antennas, variable flexible antennas, and variable fractal antennas. Now, introduction of my paper is, what is antenna? Antenna basically is a metallic structure that captures or transmits the radio electromagnetic waves. Why antenna is used? Antenna is used to radiate or receive electromagnetic waves. Antenna comes under various shapes and sizes. For example, the antenna we use in space communication is parabolic antenna. We have shape of specific bowl shape used in space communication. Now, what is microstrip antenna? Microstrip antenna is also known as patch antenna, which works at microwave frequencies. They are low profile and lightweight antennas specifically used for mobile and aerospace applications. In this figure, in this slide, we have microstrip antenna, which have 3 layers, which is first is patch, then dielectric substrate, and a ground level. Patch can be of different shapes and sizes that may be rectangular, square, circular, elliptical, or triangular. Another antenna is our fractal antennas. What is fractal antenna? In mathematics, we use the fractal geometries. That is why the name has been given to this antenna as fractal antennas. Fractal geometries are self-similar structure. Fractal design is used to enhance the bandwidth, which results in reduction of size of antenna. In this figure, we have certain shapes of fractal geometries. The most commonly used geometries are Minkowski, Koch, SIERPINSKI. Now, fractal antennas application. Applications of fractal antennas include global positioning system, radar, satellites, military applications, and in wireless networks. Now, what are wearable antennas? The antennas which are wearable by human bodies are wearable antennas. The applications of wearable antennas are in sports, military, and medical services. In this figure, we have that human body is being surrounded by wearable antennas, ECG sensor, insulin sensor, blood pressure sensor, temperature sensor, heart rate sensor, motion sensor. The all body is surrounded by wearable antennas. Similarly, in military, this army compact has been surrounded by wearable antennas all over. We have two different types of wearable antennas, that are textile-based antennas and non-textile-based antennas. Textile-based antennas are the antennas in which we use the substrate material of textile, that can be denim, that can be felt, that can be cotton, etc. Any textile-based material. Textiles are used because they are more portable, flexible, and these are used for portable antennas. Textile have small dielectric constant, due to which surface losses are decreased and bandwidth is increased. Now, another type of wearable antenna is non-textile based antennas, in which we use the substrate material of non-textile material, that may be polymer, ABS material, or any other non-textile based substrate. Many wearable accessories are made of non-textile material, and non-textile antennas can be implanted on textile-based materials such as jackets and other clothes according to our preferences. Here in this figure, we have a nail which is being made of ABS material, which is a non-textile material printed by 3D printed technique. An antenna has been printed on this ABS material. We use 3D printing for fabricating non-textile wearable antennas. Now, what are wearable flexible antennas? The antennas used to be flexible for wearable application to match the compatibility of human body. Antennas which are designed on flexible material have more sustainable performances. To obtain high gain, impedance, different flexible material different substrate material of flexible material. Now, what are wearable fractal antennas? Fractal geometry basically used to develop the compact antennas. To reduce the antenna size and dimensions, we use fractal geometries. Advantages of wearable fractal antennas are high efficiency, they have high gain, wide bandwidth, and reduced size of antenna. Now we have different antennas designed by different researchers. These are wearable fractal antennas divided in terms of frequency band, application, antenna design, fractal geometry. First one is recent wearable antenna, which is wearable coach-free fractal antenna for ultra-high band frequency. The researchers have used the rectangular coach fractal geometry for ultra-high band frequency range and applications. He has developed this antenna for the medical wireless application. The antenna design has been given in this table. The substrate material used for wearable coach fractal antenna is polyamide dielectric substrate, which is thermal resistant substrate, which is most useful substrate for human wearable application antennas. Second one is wearable electrotextile antenna. The geometry used in this wearable antenna is Minkowski fractal geometry. Frequency band used is Vibro band, which is wireless broadband band GSM 1900, and applications. This antenna can be used in WLAN applications. Third antenna is monopole antenna for wireless wearable application. The geometry using this antenna is rectangular fractal geometry, and frequency band for design for the frequency band GSM, ISM, and application. It is designed for the application wearable applications. Another antenna is Fractal antenna for on-body wireless application. The geometry used in this antenna is Koch fractal geometry. Frequency band is ISM band. This antenna is used for the application wireless body area application. And the substrate used in this antenna is vinyl polymer flexible substrate, which have very low cost. It is very beneficial if we need cheap antenna. This is comparison of various wearable fractal antennas. Now I conclude this slide by I had brief introduction of wearable antennas. Recent techniques have been studied in this paper and different applications of wearable antennas have been studied. Thank you very much. Any questions?
Any question from any of the participants? Okay, if there is no question, then thank you, Pooja.
Thank you very much, sir.
So we'll move to second presentation. And stop sharing your screen. And I request Dr. Manpreet to kindly invite next speaker.
Thank you, Pooja Rani. Now
you very
I would
much.
like to invite our next speaker, Gaurav Sikri, Research Scholar, Department of Electronics Technology, Guru Nanak Dev University, Amritsar. The topic of our presentation is efficiency enhancement of wireless sensor network using Markov modeling approach. Gaurav Sikri, please join. And your maximum time of presentation is 10 minutes. Mr. Gaurav, please start your presentation. After Gaurav Sikri, then our next presenter is Dr. Jaspal Singh. Sir, please ready. After him.
Mr. Gaurav, you are not audible. Kindly switch on your mic.
Madam, myself, Dr. Jaspal Singh, I am ready for the presentation.
Good afternoon, everyone. Sir, मेरी visible है ये screen?
Yes, sir, your slides are visible.
Okay. And good afternoon, everyone. My topic is efficiency enhancement of wireless sensor networks using Markov modeling approach. I'm research scholar in Guru Nanak University, and earlier did my MTech from Shahid Bhagat Singh State Technical Campus under the guidance of Dr. Rajni. Right now, I'm also working on a nanotechnology. So my topic is, first of all, I want to introduce about the wireless sensor networks. It is an infrastructure-less network. That means it doesn't have any kind of infrastructure. There are a large number of independent wireless sensors in an ad hoc manner, that is kind of temporary manner. Sensor nodes are used in wireless sensor networks with onboard processor as well as some batteries. They are connected to the base stations, which act as a processing unit in the wireless sensor networks. Base station in a wireless sensor network is connected through the internet to share data. And this is a kind of one diagram where we can come to know about the wireless sensor network processing. It provides a kind of bridge between real physical and virtual worlds. Ability to observe the previously unobservable at a fine resolution over a large spatio-temporal scales. It has wide range of applications like industry, science, transportation, civil infrastructure, and security. This is a kind of diagram, just a random introduction about this wireless sensor network. How does it perform? A source sends the information to the randomly to any node, and that node travels, the data travels from one node to another node randomly. But it could be a plan depending upon the different scenarios that we can use different algorithms to transfer the data from one source to the another node, and another node to the sink. And after sink, the information is being transferred to the end users. So it composed of finite number of small and low cost nodes that can sense, process, and transmit the sense data over.
Mr. Gaurav, sorry to interrupt you. Are you on first slide only, or have you changed?
I'm on fourth slide.
Actually, we are not able to see the transition of your slides.
Okay, sir. Let me see.
So have you shared only window? I think you need to share full screen.
Okay, sir. Sir, is it visible? The next slide is coming on.
Now it's visible. Yes.
Okay, sir. Thank you. Wireless sensor network is an infrastructure wireless network. It works in an ad hoc manner. Ad hoc manner is just like in a temporary manner that depends that depends upon the different parameters which we will discuss in the coming slides. Sensor nodes are used in a wireless sensor network with onboard processor and that communicate wirelessly to collect data about the surrounding environment. They are connected to the base stations, which act as the processing unit in the wireless sensor network. Base station in a wireless sensor network system is connected through the internet to share data. So next is, it provides a bridge between the real, physical, and virtual worlds. Ability to observe the previously unobservable at fine resolution over a large spatio-temporal scales. Wide range of applications are there: industry, science, transportation, civil infrastructure, as well as security. So this is the kind of GIF prepared that shows how the data is being traveled from one node to another node. The data being traveled from the source to the node, and these nodes are being selected depending upon some parameters and depending upon the mathematical approach. It is composed of finite number of small and low cost nodes that can sense, process, and transmit the sense data over the wireless system. After the sync node, the data being traveled to the end user that can process that information. Architecture of wireless sensor network, it could be a heterogeneous or homogeneous sensor nodes. Homogeneous means they have same type of environment, or they could have the same type of coverage area. But in case of heterogeneous, they have different coverage areas. One sensor node could have a better coverage area, another sensor node can have a lower coverage area. So architecture of wireless sensor network, nodes monitor the environment or system by measuring the physical parameters like temperature, pressure, humidity. Measurements then transformed into the signals that can be processed to reveal some characteristics about the phenomena. The collected data is then routed to the special node, or we can say it to be a sync node. The sync node is acting as a base station that transfer the actual data to the further computers or further end users. Then typically the sync node sends the data to the user via internet or satellite through a gateway. We can see the diagram, below diagram. That means that data is being traveled from the one node to another node, and ultimately it is being transferred to the satellite, and through satellite it could be broadcasted into the end users. So wireless sensor network applications, it has mobile communications, wireless networking technology in military applications, acoustic detection. Acoustic is a kind of speech detection or sound detection, environmental or habitat monitoring, seismic detection, medical monitoring, as well as normally used in the home appliances. So types of wireless sensor networks are of two types. One is a structured wireless sensor network, another is ad hoc. Structured has some few collection of nodes. They are pre-planned, they have low maintenance of network, but in case of unstructured or ad hoc, dense collection of nodes are there, ad hoc deployment, difficult maintenance of network. So why we opt for the ad hoc networks? Because when the network is composed of hundreds to thousands of nodes, in order to cover a larger area, we can only rely on the ad hoc networks, not on the fixed nodes. Because once any node becomes defaulter, then the data could not be transferred to the later stages, when the environment is not directly accessible by the humans attempting to construct wireless sensor networks. The components of WSN are sensor node, cluster heads, base station, end users. First is a sensor node. It consists of core component. It is a core
Gaurav, kindly conclude within 2-3 minutes.
Okay, sir. Okay, sir. We have a sensor node. core component of a wireless sensor network. It is a simple data storage, routing, and data processing. Next is a cluster. Cluster consists of a data being the dense nature of these networks require the need for them to be broken down into clusters, like the large areas being divided into different clusters. And then we have a cluster heads that transfer the data, that takes the responsibility for transferring one cluster data from one cluster to the another cluster. Next is a base station, upper level of the wireless sensor network. It provides communication link between the wirelessly, like we want to transfer from the satellite communication, we can rely on the base station. And ultimately the end user is a use for wide range of application, which gets that data from the internet. Next is a flat network routing, location-based routing, and hierarchical network routing. Flat routing that use all nodes play equal roles. In case of location-based routing, base stations route the data to the specific destinations, position awareness of sensor nodes. The distance between neighboring can be estimated on the base of signal strengths. Location-aided routing is better than the flat routing. And finally, what we are discussing about the paper is hierarchical network routing. Hierarchical network routing is better than all these two network routings, in which each cluster has a cluster head, and that cluster head further can be deployed depending upon the different parameters what we have discussed in our paper. Hierarchical network routing originally proposed for wireline networks, but now they are being used for the wireless sensor networks. In hierarchical approach, lower energy nodes are assigned to the sensing task, and higher energy nodes are used to transmit the data to the base stations. So we have a routing in this. We have a cluster member, cluster head, gateway node. Gateway node transfer data from one cluster to another cluster. Cluster head takes the responsibility for processing the data, and cluster members take the responsibility for sensing the data. And we have inter-cluster links and cross-cluster links. And clustering, we have the main approach which is being used in our paper is leech approach. It is the first hierarchical routing protocol, operates in two phases, setup phase and steady state phase, where cluster head is formed, and then that cluster head transfer the data to the base station. It uses the TDM and CDM approach. Then is leech approach is being discussed in this particular diagram. Next is leech selects few sensor nodes at a random, but in case of we have an improved version of leech as compared to
Mr. Gaurav, kindly go to conclusion.
Sure, sir.
And skip some of the slides so that you conclude within 2 minutes.
After leech, there comes the improved leech. Improved leech is used for the particular in case of traditional leech, the sensor node is being sensed, being set up. The head is cluster head is being deployed randomly, but in case of improved, the cluster head is defined by the base stations. And in case of Markov model depends upon the Markov chain, that is a kind of discrete time Markov chain. It is a kind of stochastic model that is known as a memoryless system. It never depends upon the earlier events. It depends upon the current, the next data will be depending upon the current event. The next event will depend upon the current event. It does not depend upon the previous events. So we have a Markov approach being used in our sensor networks. And now we are going to conclude this. This is enhancement efficiency. This is the kind of environment being used using a MATLAB. We have the MATLAB and deployment of nodes are there. Implementation of Markov model. It increases the efficiency of the antenna systems. So we have used this network size of 100 multiplied by 100, 200 nodes are there. These are the energies parameters being used. And these are the results being obtained. 9-volt battery is used normally for the wireless sensor nodes. And using a Markov modeling, it increases the energy, or we can say it increases the that depletion. It reduces the depletion time. Increases the depletion time. It will take the battery will have a more life in case of Markov modeling. Using leech, in terms of, if we talk about in terms of capacity, data handling capacity, leech uses 0.25 Mbps of data, and Markov is using, with leech, Markov is using 0.38 Mbps of data. If we compare three models, IB leech, improved leech, normal leach and leach with Markov, we come to know that improved leach with Markov can send the data about 0.95 Mbps of data as compared to other approaches. So this is the conclusion. Markov modeling is implemented with the leach as well as IB leach protocol. We come to conclude that Markov model with its improved version of leach can give better efficiency in terms of antenna parameters. These are the references used in the paper, and thanks for giving me more time.
Any question from the audience, please? Any question from the audience, please? Mr. Gaurav, I have one small query.
Sure, sir.
You have shown some of the results,
Yes, sir.
comparison results.
Yes, sir.
So these are your results, or you have taken from somewhere? Means this is your work, or you are?
Yes, sir. It's my work. It's my work.
It's your work.
No, I'm not discussing any papers being discussed. This is our work. I have done with the Rajni ma'am. Yes, sir.
Right,
These are the things.
So, what was your motive in doing this work? So, what you have done comparison. So, what was your objective? What objective you wanted to achieve doing this work?
So basically, I'm doing around 3 different technologies के ऊपर मैं काम कर रहा हूँ. पहले मैंने सर शुरू में जब MTech में काम किया था, तो मैंने OFDM पे काम किया था, MIMO टेक्नोलॉजी पे काम किया था, OFDM पे यूजिंग मल्टीपल टेक्निक्स. फिर मैंने नैनो टेक्नोलॉजी भी यहाँ पर कर रहा हूँ GNDU में, और मेरा यहाँ पे इंटरेस्ट भी था वायरलेस कम्युनिकेशन के साथ. तो आई कीप माई इंटरेस्ट लाइव विद द वायरलेस टेक्नोलॉजी एंड कीप सर्चिंग सोर्सेज फ्रॉम डिफरेंट थिंग्स कि आई शुड नॉट मिस दैट पर्टिकुलर मैटलैब एक्सपीरियंस. तो उसके लिए फिर मैंने यहाँ पर सर ये सर्च किया, ये टॉपिक है इंटरेस्टिंग, तो उसके ऊपर वर्क किया. आई हैव डिजाइन्ड अ कोड and then finally get these results and discuss with the ma'am, and ultimately got this kind of paper, small paper for this convention.
Right.
Actually, I'm working on two technologies right now, so don't want to miss that MATLAB experience.
Good. So thank you for your presentation.
Thank you.
So if there is no question from the audience, then we'd like to move to the next speaker. So any question from the audience, please? Yes, I think we can move on to next. Thank you.
Thank you, Mr. Gaurav. Now I invite our next speaker, Mr. Jaspal Singh, Department of Physics, Mata Sundari University Girls College, Mansa. Mr. Jaspal Singh, sir, please start your presentation. I think there is some problem. Mr. Jaspal Singh, are you here? So we're going to call our next presenter, Mr. Chandandeep Singh.
Yes, ma'am.
You can start.
I am audible. Am I audible, ma'am?
Yes, you are audible. First, you can show your slides.
Good morning to all of our requested participants and chief guests. I am Chandandeep Singh, student of Bachelor's of Technology 3rd Sem at the Yadavindra Department of Engineering, Talwandi Sabo. Today's my topic is different types of fractal antennas. Before the discussion on the topic of fractal antennas, I wish to discuss some of the communication aspects. What was the need of communication arises? Where the need of communication arises is because without an communication between any two peoples, we cannot create a society, a social living. Without any social livings, we cannot create a society. So, what is a communication system? For sharing of any types of thoughts, ideas between
Mr.
two
Chandan,
or more persons.
Mr. Chandan, you have to complete within 10 minutes. So accordingly, plan
sir.
your talk.
Yes, sir. Yes, sir. For sharing of thoughts between two or more persons, we also need a communication systems through which we can send a message from a fixed place to another place. Communication medium is the traveling route of information between the sender and the receiver. Only on the basis of communication medium, we can decide the type of communication medium. Communication medium basically of two types, wired and wireless. In case of wired communication system, we can connect any sender and receiver through the wires with any physical network. In case of wireless system, we can connect sender and receiver through electromagnetic waves. With the connection of electromagnetic waves, there is no physical connection present. In that case, a device that which emit and absorbs electromagnetic waves, that device was called antenna. And antenna is an important device in wireless communications. One of the major antenna having many types, but one of the antenna system is based over the fractal shapes that was discovered by the Benoit-Mandelbrot in 1975. Benoit-Mandelbrot discovered the fractal shapes and defined the fractal shapes. Mandelbrot defined as fractal are the broken and self-similarity structures that were present in nature and also made by human beings. The fractal shapes that made by human beings are called deterministic shapes. Natural fractals are those who are present in nature. For example, trees, river deltas. Deterministic fractal shapes that are constructed by any human being. Those fractal shapes is known as deterministic fractals. Fractal antennas can be developed by the deterministic fractal shapes. Fractal and deterministic fractal shapes again used for the antenna system fabrication. Antenna system fabrication divided into two categories. Number one is wired fractal system. Number second is patch fractal system. During the fabrication of any wired fractal system, fractal antenna system, we can bend a wire from simple bending with the simple bending of a wire from central part of its length into fixed shapes. During the patch fractal system fabrications, we can generate an antenna from the cutting of material from antenna materials. We discuss some of the types of wired fractal antennas. Number first is coach fractal systems. During the fabrication of a coach fractal system, we can replace the central part of the antenna material wire with a triangle. And with the multiple iterations, we can obtain the last structure as following as the star. So the next type is SIERPINSKI fractal systems. During the fabrication of SIERPINSKI fractal systems, replacement of central part with a square. After that, the patch fractal antennas. The patch fractal antennas are manufactured over a plate of antenna material by simply cutting the antenna materials from the central part. In the SIERPINSKI gasket carpet system, we can manufacture an antenna system by the replacement of central part with a square. During a fabrication of SIERPINSKI gasket fractal system, we remove every central part of an fractal antenna with a triangle. Features of a fractal antenna system. Due to their broken structures, fractal antennas can be used in number of advanced systems. The main benefits of the fractal system are as following. Number first is attractive multi-band and wideband working properties. Number second is the small in size and light in weight. Number third is the easy to fabrication of the antenna. And number fourth is the easiness of the installation. And as the last applications of the fractal antenna system, fractal antenna systems can be used for ultra wideband devices due to their ultra wideband frequency ranges from 2.25 gigahertz to 15 gigahertz. And second point is that due to their small sizes in the fractal antenna system can be used for the defense systems. Third point is that due to omnidirectional coverage of fractal antenna systems can be used for building communication. The fourth point is fractal systems are used for providing navigational services to the satellites. Fifth point is the huge application in Zigbee, WiMAX, and MIMO, etc. So at the last, thank you. Thank you, ma'am. Anyone having questions?
Mr. Chandan, thank you for the presentation. So any question from the audience, please? Okay, Mr. Chandan, as you have shown fractal antennas, so
Yes.
out of wired and patch, which one you consider is better for our low power communications? Or what are the advantages of each type?
Sir, I think patch antenna is better than wired antenna.
Patch is better, right? Okay. Any other question from any of the participants? Okay, thank you, Chandan. Thank you for
Thank
your
you, sir. Thank you.
Thank you, Chandandeep.
Thank you.
Now we have the last presenter of this session, Mr. Jaspal Singh, who is working in the Department of Physics at Mata Sundari University Girls College, Mansa. Sir, please start your presentation now.
Yes, ma'am. I am sharing my screen.
Mr. Chandan, kindly mute yourself.
Sir, my slides are visible, please.
Yes, sir.
Visible.
Can I start from here?
आपको WhatsApp पे link भेज दो।
Sir, your slides are not in
Full screen mode.
slideshow mode. Slides are not in slideshow mode.
Sir, press F5.
Is it okay?
No, sir. Actually, we are not able to see full screen. I think you have not shared the full screen. You have shared only one window. So that's why I think we are not getting the slideshow. Can you try to click on from beginning?
Sir, I will start.
Sir, it's not going full screen. Kindly stop sharing once, try by sharing again.
मैम को फोन में भेज दो।
Sir, is it okay?
Okay.
We
Sir,
are able to
yes.
see screen, but not in full screen mode.
Actually, on my side, it appears as the full screen.
Actually, sir, there might be problem in some sharing. Kindly click on either you start without slideshow on your screen. Now kindly click on second slide. Yes, so now we are able to see the second slide. But if you are going to full screen, then we are not able to see full screen. So if you are convenient with it, then you can start in this mode only.
Yes, sir, I am convenient with it.
Okay.
Good afternoon to all the participants on this National Convention of Engineers. Myself, Dr. Jaspal Singh, Assistant Professor in Physics at Mata Sundari University Girls College, Mansa. The today's presentation is about the introduction of a quaternary Husserl compound LiTiCN, that is lithium titanium cobalt antenna, by using the theoretical research work of the density functional theory, which is also known as the first principle approach. This is the presentation plan. Actually, this work is totally my own research work that I did in the previous months and then put in this of the convention. Here we use the computational approach to investigate the thermoelectric materials. Actually, the main aim of this paper is to introduce a new thermoelectric material, which is the coordinate useful compound, because thermoelectric materials are those materials which are capable to generate the electric energy by the use of waste heat. Wherever it will be waste, then the thermoelectric modules can be installed. Here, one of the equation Z is shown, which is equal to S square, that is the Seebeck coefficient, a fundamental character of the material to convert the heat energy into electric energy. Sigma is the electrical conductivity, T is the temperature, and Ke stands for the thermal conductivity of the electrons, means the part of thermal conductivity due to movement of the electrons, and Kl is due to the lattice vibrations. This research work is totally based on the two softwares or the theoretical components known as quantum espresso code and the bootstrap code. Here we use the GGA, known as the generalized gradient approximation, because quantum espresso is the one electron to many electron approximations. Those all the approximations are used here. In the results and discussion, the presented compound lithium titanium cobalt 10 stabilizes into the face-centered cubic structure, where all the atoms having the electron configuration is such that their outermost electrons got the 18 valence electron count. And finally, it gives the indication of the semiconducting characteristics. The structure is shown in the figure. This is the most important part of this research work, that is the bands, means the conduction and valence bands. At zero level, there is the Fermi energy level, below which it is showing the valence band, and above which there is the conduction band. The density of states, that means the how much of the states will occupy the energy for the contribution in the valence and in the conduction band. It is clear that from the red lines in the part A of this figure, that the valence band maxima and conduction band minima lies at the different points of the Brillouin zone, due to which it gives the indirect band gap. And this band gap is about 8.5, that lies in the nature of the semiconductors. The density of states is showing the contribution of various orbitals of the atoms. This is the phonon distribution or dispersion curves, which is also known as the vibrational properties. It gives the vibrations of various atoms of the compound along the 3 axes, means in 3-dimensional space. It can be categorized as the low frequency band and the high frequency band. The high frequency band is due to the lower mass of lithium than of the other atoms, because we have been observed that the lower mass atoms will vibrate with higher frequency and the higher with lower frequency. These are the thermoelectric properties, which is the most important part of this work. Here we calculate the Seebeck coefficient, that is the fundamental character of any material, which is the ability to convert the heat energy into electric energy. The second one on the first row is the electrical conductivity, and then Ke, that is the electronic part of thermal conductivity, and Zt is the most, means the prime factor of the thermoelectric performance, which gives the capability or the catalog of conversion of waste heat to electric energy. That is more in the negative range of mu. Mu is the chemical potential. It's showing that it will be good thermoelectric material in its P type. P type means due to the conduction of holes. The lattice thermal conductivity of the material decreasing with increasing temperature, because due to increasing temperature, the scattering of phonons will increasing. That also decrease the lattice thermal conductivity. We also calculate some of the elastic and mechanical properties. This is concluded that the material is an isotropic nature. This is of the ductile nature and suitable to be wired or rolled structures. And it is exceptionally suitable for the thermoelectric applications. Finally, we conclude that the presenting material is P-type semiconductor nature with of the band gap 0.85. Even its figure of merit ZT is 0.16 at 700 Kelvin, but its melting point is about 2000 Kelvin, due to which it can also be studied further at the high temperature because its melting point is very high. So this of the material as the coordinate histology compound is present for first time by the theoretical research, and it can be very beneficial for the experimental research areas. These are the references. Thank you so much.
Yeah, thank you, Dr. Jaspal, for a nice presentation.
Thank you so much, sir.
Any question from any other participants, please? So if there is no question, again, I would like to thank Mr. Jaspal for the presentation.
Thank you so much, sir. Thank you so much.
So with this, we are coming to end of the first session of the National Convention. So in this session, 4 papers were presented by the presenters. So all the papers demonstrated good findings, good efforts by the researchers. So I congratulate all the presenters for their effort and for nice presentations.
Thank you very much, sir. And all in this session, all the presentations are very good. And so we are going to conclude the technical session 1, and we are moving towards technical session 2. Thank you very much, all of you.
Before we can understand gain and phase margin, we first need to understand gain and phase. Now, I covered this in the first few minutes of the introduction to Bodhi-Plasma, but I'll sum it up here. Let me draw a linear time invariant system, G of S, which acts on an input and generates an output. When the sine wave is played with, it's distorted based on the properties of G of S. That distortion for an LTI system comes in 2 ways. The magnitude of the system will change, and the phase of the system will change. Gain is the proportion.
Good afternoon, everyone.
So if the output is twice as high as the input, we'd say that this system has a gain of 2 because it multiplied the input by 2. And similarly.
Good afternoon, everyone. Myself, Gurpreet Bharti, Assistant Professor in ECE section at Yadvinda Department of Engineering, Talwandi Sabo. Now we are going to start technical session 2 of National Convention of Electronics and Telecommunication Engineers and National Seminar on Antenna Design for Efficient Communication and Networking. This session is chaired by Dr. Labh Singh, FIE, former advisor to DOIT, Government of India. In this convention, we have received several research papers in the field of antenna design and networking. In session 2, we have 4 research papers Now I request all the presenters for their presentations. Now I would be like to invite first participate presenter for their presentation. First is Simarpreet, the research scholar in Department of ECE, Shaheed Bhagat Singh State University, Firozpur, having presentation.
Good afternoon, ma'am. Good afternoon, ma'am. Am I audible?
Yes, you are audible.
Good
Please carry
afternoon,
on.
ma'am. Okay, sir. Okay, I'm going to share my screen now. Okay, good afternoon, everyone. I'm Simarpreet Kaur, and I have started my PhD this year under the guidance of Dr. Rajni at Shaheed Bhagat Singh State University, Firozpur. And I'll talk about skin disease detection using machine learning algorithms.
Clear it up with a series of simple
This
diagrams.
is the outline of my presentation.
Now it's obvious that the gain is 5 at all frequencies.
As we all know that 5G is being deployed all over the world as it has increased speed, reduced delay, higher security, enhanced data rate, and lower error mobile communication systems. Although it has so many benefits, but this latest technology has other side too.
It doesn't increase the system gain by 2. If we did want to increase the system gain by 2, we have to move the block forward so it gets applied to all paths. But then if I add feedback into this
Leading to around 36 nations have informed regarding the possible harms of fifth generation wireless communication. And these include damage to DNA and tumor suppressing genetic material, increased specific absorption rate as sweat glands were.
try to be explicit about which gain we're talking about in the rest of this video, especially when I'm talking about the open loop system versus the closed loop system. Okay, now let's talk about margin. Margin is the extra amount of something.
Skin cancer is the unusual growth of skin cells, which may spread to other parts of body through lymph vessels in later stages. And this stage is irreversible. This is one of the major cause of death among human beings. Research shows that
how stable is stable. Designs that have less margin are considered less stable in a sense because smaller variations in the system could cause instability. Now, I have a real quick side note. I don't know if
detection process. As a result, reaching later stages causes death. In such cases, timely detection and correct diagnosis is a cost-effective way, is highly needed. Timely detection of such life-threatening disease play a vital
your system go unstable. So now you might wonder why we design a system with margin built in the first place. Well, usually when you're designing a control system, you're doing so based on a model of the system with mathematical equations.
accurate leads to appropriate treatment and turn to be life-saving. Such systems are generated through artificial intelligence. Artificial intelligence-based models are used for diagnosis purpose by implementing various machine learning techniques due to its high accuracy and speed. Learning takes place either through manually clicked pictures of skin or sample data available on internet or other kind of dermatology clinics. The system displays the name of disease as output based on pre-trained data. Totally non-invasive. This system is totally non-invasive and cost-effective in nature. So this is the literature review. I have reviewed a number of papers starting from 2012 to 2021, and detailed information was taken from them, such as the year of publication, data set, number of images, classification algorithms, and accuracy of the same. Now, this is the table which shows the review of literature in a study undertaken in 2012. 21 images were taken from internet, and the model was generated for skin cancer, and the classified used for the same was artificial neural network, and the system was found to be efficient. In 2017, another study was undertaken which took 20 photos from internet, and the model was again generated for the skin cancer, which used classifier support vector machine, and the accuracy achieved was 95%. And in another study undertaken in 2017, online repository was used, DermNet, NZ, and DermQuest, and the six diagnosing melanoma, eczema, and acne. And classified used was bag of features, and the accuracy achieved. Season 3, and it was found that artificial neural network was efficient up to 92%, and the KNN was the least accurate, that was 82%. Another study was undertaken which took ISIC as and back propagation algorithm, and the system was found to be high efficient. Another study was undertaken which used DermNet and DermWeb as online repository for taking the images, and the diagnosis was made for skin cancer. Diagnosis was done for melanoma, which is a kind of skin cancer, and classifier used was again support vector machine, and the accuracy achieved was 90%. In another study undertaken in 2019, 80 images were taken from was used as a data set for obtaining 10,015 images, and the diagnosis was done for melanoma, intraepithelial carcinoma, and basal cell carcinoma, etc. Classifier was convolutional neural network, and the accuracy was 77%. ISIC was used as data set for obtaining 351 images of different skin problems like melanoma and basal cell carcinoma and actinic keratosis. Basically, these are the cancer. And next is the classifier used was support vector machine, VGGNet, and inception model. Best accuracy was achieved with inception model. Now, another study undertaken in 2020 used 180 images, and these images were actually obtained from different dermatology clinics and health centers, and it was used to diagnose various skin diseases like acne vulgaris and some kind of cancer also. The classifier used was support vector machine, artificial neural network, and artificial neural network was highly efficient, that is 96% to 100%, and SPM was 93% efficient. PH2 was used as a data set for this diagnosis of skin cancer, and 200 images were used for this purpose. Classifier used was support vector machine, and 90% accuracy was achieved. Another study undertaken in 2021 was designed, the study, a model was designed for detection of skin cancer through this study, and the classifier used was support vector machine, probabilistic neural network, and random forest, and the system was found to be efficient. And in another study from hospitals and internet for melasma, eczema, psoriasis, onychosis, and acne and CONT. And the classifier.
Excuse me, Simmerpreet. Now, can you conclude, please? Can you conclude? Because
yes, sir.
we have got a short
okay, sir.
Time. Yeah.
Okay, sir. Okay, sir. Okay, for sure. Okay, diagnosis of skin ailments at an early stage helps to cure and enhance patient's probability of improvement and survival. Actually, a number of models can be generated with the help of machine learning. But I have studied that models with number of algorithms, where more number of algorithms are used, they are highly accurate. And the 5G wireless communication technology has serious damaging effect on whole human body. And so I think this is very important to make new policies regarding the use of selection of frequencies and regulation of SAR of gadgets using 5G. And these are the references.
Okay. So, I mean, thank you very much for the presentation. I think you have touched many good points and new points about the skin cancer being caused by the radiation. Like, have you studied or linked it with your any other frequency, like less than 5G, maybe 4G, 3G also? I mean, have you tried to compare that? That is one thing.
No,
And
sir, I
secondly,
haven't.
the cases which you have studied, are they all due to radiation only? I mean, how much percentage of these cases is due to the radiation? How much is due to other regions? Have you tried to classify that also?
Sir, actually, I haven't done this yet because I
Yeah.
have started my
So,
PhD in this year only.
so my
And
suggestion
I'll
would
be
be
doing
that,
this for.
yeah, in future, kindly do that. And I mean, you have really done wonderful work. But then I think we can't just, I mean, as a layman, if somebody thinks, we can't
Yes,
just blame 5G for skin cancer, you know.
yes,
So,
sir. Yes,
so you
sir.
have
Yes,
to,
sir.
when in the conclusion, I mean, otherwise people will be afraid of using 5G, you know, every time. So,
Yes,
I mean,
sir.
that
So
is
this is a very good
from
suggestion.
the citizen and from the public angle. Yeah. Yeah. Thank you.
Yes, sir.
Thank you very much. Please carry on.
Thank you, sir. Thanks a lot.
Thanks,
Gurpreet,
Simranpreet.
we can go to the second
Yes,
scholar,
yes.
please.
Yes,
Yeah.
sir. Thanks, Simranpreet. Our next presenter is Jagdeep Singh, student, Yadvindra College of Engineering, Talwandi Sabo. Presentation topic, H and inverted U-shaped compact multiband antenna for mobile communication, WiMAX and satellite communication applications. Jagdeep.
Good evening, ma'am.
Good evening.
Ma'am, am I audible?
Audible. Please carry on. Carry on.
Ma'am, I'm actually not able to share the screen.
What happened? Jagdeep?
Yes, ma'am.
What happened?
Actually, ma'am, I'm not able to share the screen. It's showing that other participant is sharing the screen, so I'm unable to do.
Simranpreet, please stop sharing your screen.
Okay, ma'am. Good evening, everyone. My name is Jagdeep Singh Sandhu, student MTech EC, Yadvindra College of Engineering. I'm here to present a research paper on HN inverted U-shaped compact multi-band antenna for mobile communication, WiMAX, and satellite communication applications. First of all, the topics covered in this presentation are: what is an antenna, the parameters of antenna, microstrip patch antennas in specifically, and the proposed antenna design and simulation, evolution stages of the proposed antenna, the parametric performance of the proposed antenna, and finally the conclusion. First of all, the wireless communication. It's the transmission and reception of data over free space using electromagnetic waves. Now, obviously, wireless communications, it gives us freedom from wires, lower installation and maintenance charges, higher security, connectivity over remote areas, and flexibility to connect multiple devices. These are some various frequencies, the basic frequencies that we use daily in our daily life: the FM, GSM, 3G, 4G, 5G, Bluetooth, and WLAN. Now, what is an antenna? Antenna is basically a transducer that converts electrical energy into EM waves and does the opposite on a receiver. It is basically an interface between guided media and free space. Now, the antenna parameters are: first is the radiation pattern. Radiation pattern describes the relative strength of the energy radiated or recepted around an antenna as a function of direction and distance. That is how much energy has been radiated or recepted and in which direction. It has basically 3 lobes: main lobe, the area where maximum energy is radiated, side lobes, and the back lobe. Now, second is antenna gain. Antenna gain describes how much power has been transmitted in the direction of peak radiation to that transmitted by an isotropic antenna. Mathematically, it is equal to 4 pi into radiation intensity of the antenna over total input power. Now, third parameter is directivity. It is the ratio of radiation intensity in a given direction to radiation intensity averaged over all directions. Basically, antenna gain and directivity are almost same things, but the thing is efficiency is taken into considerations while calculating the gain of the antenna. So if we say the efficiency of the antenna is unity, then gain will be equal to directivity. Now the fourth parameter is reflection coefficient. Now, whenever a signal is radiated from source to load due to impedance mismatching, what happens is reflection occurs. Now that reflected signal magnitude and the incident signal magnitude, a ratio of those signals is called as reflection coefficient. Now the fifth parameter is input impedance. It is given at the antenna terminals, given by R in plus J X in, where R in is the resistance of antenna and X in is reactance of antenna. The last parameter is voltage standing wave ratio. It is a measure of impedance matched of an antenna with the transmission line. That is, whenever mismatching occurs at the load side, what happens is we have an incident signal and the reflected signal. They both signals interfere with each other and give rise to a standing wave. Now the maximum of that standing wave to the minima is called as VSWR, ratio of those two waves. Now we come to the point microstrip patch antenna. A basic microstrip patch antenna consists of a radiating patch on one side of the dielectric substrate and a ground on the other side of the dielectric substrate. These are the different feeding techniques of the antennas, microstrip patch antennas. First is the line feed. We have a simple conducting strip on the substrate connected directly to the patch. In coaxial feed, we have a coaxial cable connected beneath the ground, from beneath the ground to the patch of the antenna. We have the outer conductor conducted to the ground while the inner conductor is soldered to the patch. The third feeding technique is aperture feed. Here, two dielectric substrates are used with ground plane in between those two dielectrics. Feed is on the lower substrate while the patch is on the upper substrate. There is a slot cut in the ground plane so that the feed can be electromagnetically coupled to the patch. Fourth feeding technique is proximity coupled patch feed. Here we have two dielectric substrates such that the feed line is between the two substrates and the radiating patching is on the top of the upper substrate. Now, while we compare these four feeding techniques, we can easily find that line feed is the simplest of all those four techniques, but it provides lesser gain and lesser impedance matching. Aperture feed and proximity coupled feed are contactless feeds, that is, energy is radiated to the patch of the antenna electromagnetically. Now the advantages of microstrip patch antennas. Microstrip patch antennas are of lightweight, low volume. Their cost of fabrication is low. They are mechanically robust. We have lots of patch shapes available in microstrip patch antenna. Very versatile in terms of resonant frequency and capable of multi-band operations. The disadvantage of patch antenna is narrow bandwidth, low efficiency, low gain, and low power handling capacity. Now, some of the applications of patch antenna are mobile communications, satellites, aircrafts, and wearable body antennas. Now we come to the proposed antenna design. While conducting the literature survey for various antenna designs that are in which the patch is made up of using alphabetical shapes, we have tried to fabricate a new antenna using two alphabet shapes and an inverted U. And on that inverted U structure, we have two rings on the each side of the U structure. This diagram depicts the evolution stages of the antenna. Like we started from a single H structure, then we add another H structure, then an inverted U, and then finally on the fourth proposed antenna structure, we added two rings on each side of the U alphabet. We can easily see in proposed antenna, the number of bands have been increased. The number of bands in our proposed antenna are 8. And these are some of the parametric variations that we have done on the proposed antenna while checking that what effects on the performance of the antenna these have caused. This first is the feed line width variation. We have varied feed line width from 1 mm to 4 mm. While in our antenna, proposed antenna structure, our feed line width is 3 mm. So the 3 mm has been optimized to give the perfect performance parameters. Similarly, in this diagram, we can see the effect of the width of H alphabet on the performance of the proposed antenna. By increasing the width of the H alphabet, we can easily say we have increased, we got a band at 1.8 gigahertz. 1.8 gigahertz, we all know, can be used for the GSM applications. So these are the dimensions of the optimized proposed antenna design. Now features of the proposed antenna are that our antenna substrate is of 30 mm into 27 mm with a height of 1.6 mm. Substrate used in this proposed antenna is FR4 having dielectric constant value 4.4. The patch consists of, as we all know, two symmetrical H-shaped alphabets with an inverted U-shaped branch. The inverted U-shaped branch has two ring structures on each of its side. Also, microstrip line feeding is used with a field line width of 3 mm and length of 3 mm. These are the performance parameters of the proposed antenna. We are getting 8 bands right from the 1.8 gigahertz to 14.7 gigahertz. Return loss for every frequency band is very good. We are getting up to maximum of 31.60 decibel of return loss. The gain of proposed antenna is also very good. The minimum gain has been obtained at 11.67 gigahertz, equal to 2.63 decibel, while the maximum gain has been attained to be equal to 11.60 decibels. This is the reflection coefficient of the proposed antenna. That is the simulated proposed antenna on the HFSS software. These are some of the diagrams, simulated diagrams of the proposed antenna design. This is the antenna gain. These are the radiation patterns of the proposed antenna at each frequency. And these are the surface current density of the proposed antenna at each of the frequency. I would like to conclude this presentation that this antenna offers multiple band frequencies at 1.8 gigahertz that can be used for GSM operations. 3 to 3. Gigahertz, this can be used for WiMAX applications. 5.72 to 6.2 gigahertz, it can be used for fixed satellite communications. 9.2 gigahertz for maritime radio navigation. 11 to 12.62 gigahertz for X-band satellite communication, and 13 to 15 for direct broadcast satellites. While the proposed antenna has been optimized to give good results, there is still scope for improvement in performance. Like we can use neural network techniques, fuzzy logic. Also, we can change the substrate material, or we can change the feeding techniques. So if there is any question.
Thank you, Jagdeep. This was a very good presentation. Actually, इसमें आप you can do one more thing, like existing design of the antenna and the proposed design. How do they compare as far as the power consumption is concerned? Because that's a very big feature which will decide that it should go. Can it be made commercial or not? If the design can be made commercial, only if the power is not increased power consumption, because otherwise it can't be commercially viable. So that part also you can add in the.
Yes, sure, sir. I will do that.
Thank you. Next caller, please.
So next caller is Vineet Kumar. He will not join this session because of having some technical problem.
We can go to the next. Next one.
Yes, sir. Next is Mageshwari S, Assistant Professor, National Institute of Technology, Trichy, India. Our topic is nonlinear PID controller based voltage reference control of DC-DC converter. Mageshwari, please share your screen. Mageshwari.
Yes, I am there, ma'am. Good evening, everyone. I am Malarvari from National Institute of Technology. I am doing my research under the guidance of Dr. S. Mageshwari in the Department of Electrical and Electronics Engineering. I am going to present the paper of nonlinear PID controller based voltage reference control of DC to DC boost converter. In many applications such as data communications, high voltage power transmissions, renewable energy applications, robot controllers, and factory automations, we need flexible power conversion. For this, we almost need a power. It is possible only through power electronic converters. So in many fields like these, we almost rely on power electronic converters in the current technology world. Here in this list, here we have taken a closed loop control of DC to DC boost converter. We have large amount of controllers, but still for closed loop control of DC to DC boost converter, PID controller is the most popular one. But the noted disadvantages with PID design tuning of PID gains. So that's why here the objective is to design a high effective controller. Here a nonlinear PID controller is designed for the closed loop control of DC to DC boost converter. This is the design of closed loop control of DC to DC boost converter with nonlinear PID controller. This is conventional PID controller. With this block, nonlinear gain is added with conventional PID controller. That's why it is named as nonlinear PID controller. And for this project, we have taken a switching frequency of 20 kilohertz, input voltage is 12 volts, output voltage is 21 volts, capacitor is 97.22 microfarad, and in inductors 1.26 millihenry, resistance is 24 ohms. And this is the closed structure of DC to DC boost converter. Why we need to go for nonlinear PID controller? We have already stated that the closed loop PID controller is the most popular among industries when we go for closed loop control of DC to DC boost converter. Why? Because in the sense it possesses faster transient response compared with others. But the noted disadvantage is it having a less tracking efficiency, which means even though it tracks the reference value in the accurate manner, but still the steady state oscillation is more because of integral action. These oscillations can be damped with the derivative action, but it should be properly tuned. Unless it is not properly tuned, then it is a big issue. That's why we are going for nonlinear PID controller for overcoming the disadvantage of less tracking efficiency due to higher impact of oscillations with conventional PID controller. We are going for nonlinear PID controller. How it is designed, let's see. This is the structure of nonlinear PID controller. As it is already stated that the nonlinear gain is added with PID controller. That's why it is named as nonlinear PID controller. How? With the reference value, this error signal initiates the control action. From PID controller, the controller is directly proportional to the error response. By eliminating the proportionality with the proportional action, integral action, and derivative action, it has the structure like this: Kp of t plus integral of k e of t plus kd d of t by dt. This is the conventional PID controller. This is responsible for increasing the speed of response. Integral action is mainly for reducing the steady state error, and derivative action is mainly for damping the oscillations. And here we are going to add the nonlinear gain. That's why it is a nonlinear PID controller. Yes, let's take E of t and K of E out of this. We can have the controller is like this. And we can have this K of E nonlinear gain can be any form of nonlinear function. Then we can have nonlinear function of error is equal to E of t into K of E. K of E, and we can have the controller part is taken as instead of E of t K of E, we can substitute psi of E. With this, we can make this block diagram. For the design of nonlinear gain, we made this block diagram like this. We made the block diagram as like this. According to the proposed stability criterion, we are going to design a nonlinear gain. This is a linear part and this is a nonlinear part. And with this E of t, K of E, we are going to, with the reference value of 0, it is given as minus psi of E. Minus psi of E is added with PID controller and G of S. We are going to have minus E of t, and R of t minus E of t is going to be E of t. According to proposed stability criterion, the transfer function of upper portion must be strictly positive real, and if the system is asymptotically stable based on hyperstability criterion, then the lower portion meets the condition which is given as follows. Between the time intervals, the psi of E and into E of t into dt must be greater than or equal to minus y naught squared. This y naught squared must be a positive definite number. With this, we are going to design a K of nonlinear gain. Yes, we have already said that conventional PID controller, the error must be controller is directly proportional to error. We have closed loop control, we have transient response and steady state response. In transient response, the error is large. When it is directly proportional, the K of E must be large enough to control the error as quick as possible. In steady state response, it is too small, then K of E must be small and should give the control over the steady state response without any oscillations. And with this, we are going to make the K of E it can be any nonlinear function, the nonlinear function. Hence, it is given as K of E is directly proportional to exponential base of error. Then by eliminating the proportionality, we have given K of E is equal to Kn beta E, beta par E. And then Kn and beta must be greater than or equal to 0. With this condition, we have the error of system is given like this. If beta is between 0 and 1, if error is less than or when we take on the left side of the graph, if error is greater than or equal to minus Emax, we can take the error as set is. If the error is less than minus Emax, we can take the error as minus Emax. We can strictly limited with this Emax. The Emax is user defined one, which can be applied according to the application. When beta is greater than 1, if the error is less than, when we take the right portion, when error is greater less than or equal to minus plus Emax, we can take the error as it is. But if it is greater than plus Emax, we can restrict the limit as Emax. Then, but the condition is already given according to the proposed stability criterion, we can have E of t instead of K of E, we have substitute Kn beta per E, E of t into dt. Instead of Kn beta per E, we can also write like this as E power E, here this E is error, E lambda lambda beta. Then we can take K of E is equal to Kn E power E lambda beta. We can also make this E is equal to lambda beta. We can substitute this Kn E power E. Kn and beta must be greater than or equal to 0. With this, we can have the two conditions. When beta is less than 1. If beta is less than 1, it is already stated as beta must be greater than or equal to 0. If it is 0 to 1, then it is always a land 0 to 1, it is always gives a negative number only. So we can have beta is equal to E power minus E. We can also write this. Then we have minus Emax. Let's come in this order left from left. When it is less than minus Emax, it is already said that it is minus Emax. Then we can substitute this. We can have A Kn E power Emax. Then if it is 0, then we can have E power 0 is 1, then K of E is K of Kn, simply Kn. If it is plus infinity, E power minus infinity is going to be 0. If it is greater than 1, it is always a positive number. With this, we can have Kn is equal, K of E is equal to Kn E power AE. With this, from the left hand side, minus infinity, when you substitute minus infinity, then it is K E 0. And if it is 0, then we can substitute Kn E power 0 is Kn. Simply it is Kn. When you substitute E power max from this graph, you can have Kn E power E max. What happens here? Here we can have the limit of, from above two cases, we have the limit of ki, km and kmax is 0, kn e power ae max. The controlled performance of any controller can be stated. How it is effective can be said by the lower bounded case. When it is too difficult to control, when the error is too small. Even if it is proportional, if the error is too small in the sense, if it is e power minus a, something like that, it is too difficult to control. So effective control completely depends on lower bounded case. Here, here we have lower bounded case as 0, which is insufficient information. So we have modified the lower bounded case nonlinear gain by combining of above two cases, that is e power ae plus e power minus ae. We can have another case kn casket ae. With this we can have, when we substitute e power 0, then it is simply kn. If a is greater than e max, then we can have kn ae max. With this, the lower bounded case is improved.
Yeah, excuse me, can you conclude please?
Yes, sir. Yes, sir. Okay, fine. This is a state space average model of boost converter. From the transfer function taken, we have taken the response of PID controller and non-linear PID controller. From the graph, we can have here 3000. It is settled, but here it is settled with 400 seconds also. From Bode plot, it can be seen that the phase margin is increased. Higher the phase margin, higher the stability. This is the time domain specifications of PID and NPID. From this, we can have how it is greatly improved. By the number, we can say how it is greatly improved. Rise time is also, it is higher in the sense it is improved. From this graph, we can from this table, we can understand that how the time domain specifications of is greatly improved, of the system is greatly improved. And this is the closed loop control of boost converter response. For the voltage it has taken, it is how great the oscillations is. Here it is considerably reduced. From this, it can be concluded that nonlinear PID controller ensures faster tracking of reference value with less oscillations, and also with less oscillations itself, we can understand that it improves efficiency, and also it reduces the complexity of tuning of PID gains. If it is properly tuned, then we have a effective control performance with the control structure of a PID, but it is not, we have not such tuning methods. And it provides a non-linear relationship with the error. As conventional PID controller is, it is in linear relationship with the error. And that's it. Thank you. Thank you. Thank you, sir.
Thank you, Malavili. This was a grand performance. Which simulation software tool you use for this?
MATLAB simulation, sir. MATLAB Simulink.
Do you think there is any scope of applying AI and ML test also to this for validation purposes?
Sir, I cannot get you, please.
Can you use that AI and machine language ML techniques also for simulation purposes?
Yes, sir. Yes, sir. Of course. Artificial intelligence and everything.
So there is a future scope also for this. So you can note down that.
Yes, sir.
Try that one.
Thank you. Thank you, sir. Thank you so much.
Okay. Thank you, Madheshwari. Thank you, sir.
Yes.
Thank you, all the participants.
गुरप्रीत कोई रह गया अभी और
नहीं सर एक स्टूडेंट रहंदा वो कल करेगा वो ना टेक्निकल प्रॉब्लम
okay no problem so in the end thank you very much Gurpreet first of all Professor Gurpreet, and this has been a wonderful organization by you, and in fact I will congratulate Simarpreet, Jagdeep and Malavili for excellent scholarly work, and I wish them all the best. Thank you so much.
Thank you, sir.